Sorry, everybody. I had it on a loop. Well, here we go. It's been a while. I haven't done one of these in a while. Greetings, junior scientists, citizens of the great, big, weird, wild, and wonderful world in which we live. As always, I'm your humble science communicator, the great Orbax, coming to you here from the bowels of the McNaughton Building at the Department of Physics at the University of Guelph. Hi. How's everybody doing out there on the internet? I haven't done a live stream for, I guess, a year since the last time I was lucky enough to get to do one of those RASC Montreal yearly outreach missions that we do. And in fact, this is our 5th year of collaborating with the Royal Astronomical Society of Canada's Montreal Centre. And I'm excited. We've got a great speaker tonight, somebody from actually in Guelph, which is fantastic. And I don't want to take too long before we get into it, everybody. But hello to everybody out there online. Oh, Saxon's online. Good to see you, buddy. I'm glad you're able to make it. Not working behind the board this time because one of my students has actually graduated. It's finally happened. One of our behind-the-scenes producers has actually gone on to start a life on his own. But we're excited to see everybody here. So, without any further ado, because I'm rambling on as I happen to have a propensity to do, as mentioned, I'm the Great Orbax. I run a lot of our outreach events here, and I'm a production specialist for our online education content here as part of the Department of Physics at the University of Guelph. So thank you and welcome everybody in. If you want to check out some of the stuff that we do here at the Guelph Physics Department, then check out Guelph Physics on YouTube, Facebook, on Instagram. We have a library of these live videos like these ones, of pre-recorded videos of interviews with former alumni and with our current staff and professors here in the department. But tonight is not about that. No, tonight is not about talking about things that are inside a building. It's about talking about things that are outside of a building, namely up higher than buildings are, in the sky, beyond our clouds. Yes, that's right. Tonight's a night for astronomy, for dreams, for searching beyond the edge of those clouds and trying to peer into the cosmos beyond, in a way of attempting to understand the universe and all within it. And who else but to answer those questions that I'd like to welcome onto our live stream. Please put your virtual hands together for Nader from the Royal Astronomical Society of Canada Montreal chapter. Whoa, there we go.
Thanks.
How's it going, Nader?
It's very hard to beat your upbeat. It's just you woke me up.
Well, if it helps, it's completely fabricated. So I'm running the ones and twos here. I'm already cheating, and you can see some of the people who are actually already going to be on the stream and presenting later tonight. But Nader, go ahead and tell us a little bit about the Royal Astronomical Society of Canada Montreal Centre and what you do.
Well, thank you very much again for this introduction. My name is Nader Dow. I'm the Director of Outreach at RASC Montreal Centre. And as Orbax said, this marks our 5th annual astronomy live stream this year. It's an event where we bring together passionate minds in astronomy, physics, and space exploration to share knowledge, stories, and cutting-edge innovations, as you're going to see tonight. For those who are joining us for the first time this year, the Astronomical Society of Canada, the Royal Astronomical Society of Canada Montreal Centre, has been fostering a love of astronomy and space science for over 100 years now. And we're a community of amateur and professional astronomers dedicated to public outreach, to education, to sharing of the wonder sky, the night sky. And whether you are a seasoned observer or just starting your journey in astronomy, we welcome you to be part of our community. And we invite you to head over our website, rascmontreal.org, and maybe join our newsletter to learn about all of the upcoming public events that we're hosting this year. And before we continue, I just want to quickly acknowledge as we gather virtually here, I want to acknowledge the land and the sky of the Indigenous people whose lands we observe from. Here in Montreal, we recognize the Kanien'kehá:ka and the Anishinaabeg, as we acknowledge a lot of other Indigenous people across Canada and North America. This month marks the snow blinding moon, as the Mi'kmaq of the East Coast would like to call it. It's the moon that ushers the harsh conditions of the winter this time of year, when the low rays of the sun reflecting off the snow makes visibility very difficult. And before I hand the virtual floor back to Orbax, I just want to mention that in the couple coming days, on February 7, there is a public a lecture at the McGill-Ulster Library. It's host a talk about Galileo and Kepler's scientific revolution that you can just look it up and can join online. And on February 21st, there is a mobile planetarium show and citizen science activity at John Abbott College beginning at 7 p.m. That's everything from me. I'll hand the floor back to the great Orbax.
Well, speaking of mobile planetarium shows, wouldn't you know it that our mobile planetarium will actually be at the Perimeter Institute for a Galileo exhibit taking place for most of February. So February this weekend, which I believe is February 8th, Saturday, and then on Family Day, the 17th, I believe, similarly to you, we will be at the Perimeter Institute, where we'll be showing a film about Galileo and about his discoveries in conjunction with their ongoing exhibition about Galileo as well. So it's pretty exciting stuff. And I have to point out, you know, you Rask kids are so humble about what you do and the outreach that you do. But, you know, I'm constantly contacted by young people, by old people, by just people of all age ranges altogether who are looking to get into astronomy. And the one thing that I tell all of them is to reach out to a Royal Astronomical Society center in your community. They're across, how many units do they have across Canada now? An exceptional amount.
About 60 maybe.
That's incredible. So you could realistically say that within an hour of wherever you probably are in this country, with a few exclusions, you're going to be able to find some of these incredibly kind and incredibly interested experts who just want to help spread astronomy throughout our population. So I often recommend people go to a meeting and bring their telescope as well if they're just getting into this type of thing, because there's always volunteers there who can help you. Am I correct?
Yeah, and even if of people who don't have any telescopes, every member is more than happy to share what they have with the public. You don't have to be spending hundreds and thousands of dollars on your first telescope until you go there and find out whether it's something that you want to do and take as a hobby or not.
Yeah, it's fantastic. Incredibly knowledgeable people. It's a great organization to become a part of. And, you know, if you're interested and you can't say, let's just say you can't make it out to a Rask event. And let's just say it's like it's been here in Guelph for the last 3.5 months, and you can literally not see anything when you look up into the sky, except for the constant cover of clouds that we're always trying to peer past. Then what you might be interested in is taking a look at my monthly stargazing guides, which come out on this YouTube channel, done in corroboration with the Royal Astronomical with the Society of Canada, Montreal chapter. February is coming soon. Well, basically, it's not ready yet because I was lucky enough to be in Hawaii last week and actually go up Mauna Kea and see the observatory array up there, 14,000 feet above sea level, halfway up Mount Everest. So that was an incredible.
It's literally breathtaking.
You know, honestly, it was. I've never been in a situation like that. When you go up to the visitor center up there, which is 9,000 feet up, you actually have to stop, and they keep you there for half an hour to make sure that you acclimatize while they check out your car and make sure you have four-wheel drive. And then it's only 3 switchbacks to go up another 6,000 feet. When I was up there, it was like being on a different planet, I assume. I mean, it's all volcanic rock, all basalt, and you can barely catch your breath. And from images that I've seen of Mars and the moon, it's very difficult to breathe up there. Am I right now? Yeah. Fantastic. Well, I don't think we should wait any longer. We've got an incredible group here. And I'd like to point out again that if you happen to have questions about what we do here at Guelph Physics, what they do over there in Montreal with the Royal Astronomical Society of Canada, or any questions for our guest who's going to be coming up here in a few moments, we've got an active line right here taking a look at the chat as it comes in. We're going to do our best to answer your questions perhaps after the talk, but if there's anything about outreach or anything like that you want to talk about now, well, we can address that as well. But without any, oh, somebody's watching from Guelph, Ontario. Look, I can do this. Hi, Brian. Welcome in. Look at all this technology I have literally at my disposal, just at my fingertips. But yeah, we'll take an effort to actually chat with you as no, I can't do both talk and run technology at the same time as I can. So without any further ado, I would like to welcome in our guest for the evening. I was lucky enough to meet our guest. Geez, Brian, what would it have been? I mean, I know you're muted right now, so you can't answer, but it would have been maybe a year and a half ago at a public talk you were giving on campus, where I went because I was interested in the idea of astrophotography and getting our observatory up and running here on the top of the McNaughton building at the University of Guelph, the Department of Physics, where we went and met. And not only was I blown away by the astrophotography, but I was introduced to this incredible idea of 3D printing actual telescopes as a way to make them available to the population at large, and as a way of demystifying it and really just getting your hands on these incredible pieces and opening doorways into the unknown. So without any further ado, please put your internet hands together for Brian DeLauder, the founder of 10 Telescopes. Bring him in here, see if I can do this. There we go. Welcome in, Brian.
Thank you very much, Orbax. And thanks, Nader, and to the University of Guelph and the Montreal RASC for hosting me this evening.
Yeah, no problem. Now, I mean, I'm sure you're going to get into all of this as we go along. But first of all, I would like to point out, before we get into any of this, I'd like to point out that some of you who follow the Guelph Physics Instagram have probably seen our Griffin scope, which was an incredible 3D printed telescope done by you. And I don't want to step over anything that you're going to cover in your presentation. So if you're going to no spoilers. This is a spoiler-free zone, everybody. So if you're going to get to some of these things, just tell me to forget it and that you'll move on. But my question to you, and I like to try to, because we talk to a lot of physicists on here, and we try to humanize them a little bit for the public before we get too far into their talks. I'd like to ask you, what brought you to a point of fascination with astronomy, with the stars, with the world beyond, with the worlds beyond our worlds?
Well, that's a great question. So I would say it definitely started when I was growing up on a farm in rural Ontario, and we had these just incredible dark skies that you have to drive, I think, hours, certainly at least an hour away from most cities to get a sky like we had on the farm. And I definitely remember just looking up and thinking, wow, why aren't more people talking about this? What is up there? And I started buying magazines, and I got a department store telescope, and it was a really terrible telescope, but I still had a great time with it. And it started quite young for me. Yeah. On the farm.
Yeah, I think a lot of people have a similar origin, because mine was very similar as well, growing up on a farm with a little bit of distance from the city and being able to see those lights twinkling off in the sky. Luckily for us now, it doesn't matter really what farm you're on, because light pollution is so bad that you can't see it anyway. So
yeah, it's really that's a talk for another day maybe, but it would be good if we could get our skies back.
So this drove you to so this was a fascination that you've had since you were young. Did you ever find that it kind of fell into the back seat? Has it always been a thing that you've been passionate about, and it's been on the forefront of what you do?
Yes, really. I mean, as you'll see in the presentation, I'll show some of my early forays into astronomy. But yeah, it's something that I've been interested in. You know, I was always, if I went to a magazine shop, when there were magazine shops, I would always grab an astronomy magazine or two or three, and because they were there, and they were, you know, we didn't have the internet. And so that was a great way to kind of be connected to astronomy, to the people doing astronomy.
Fantastic. Well, you know what? I'm just going to let you get right into your talk, because I mean, I could talk to you all night about everything I'm interested in, as I'm sure Nader could do as well. We might as well let you lay the groundwork, you shape this conversation, and we'll join you back at the end of this with some questions from us, and also questions from the lovely people who are joining us this evening on the different streaming profiles.
Okay.
So take it away, Brian.
I appreciate it. Thanks, Orbax. Okay. So tonight's presentation, I call it the Accidental Telescope Factory, and it's a little bit of a story about how I got into making telescopes. And so, as I mentioned earlier, I grew up on a farm, and we had these wonderful skies. And I think that we have the internet now, so people are becoming familiar with the skies in a different way. But it's I think it's something I wish that more people could experience and grow up under a truly dark sky, because it's interesting when you come when your curiosity grows from what you see with your own eyes. But yeah, I started quite young, and I had a department store telescope, which was a terrible telescope. And then throughout the years, I started doing astrophotography. This is actually a film-based astrophoto that I took. This is 40 minutes, a single shot, using a film camera that was mounted on the back of a track telescope. And back then, we used illuminated reticles. We didn't have guide cameras or anything like that. But I would use an illuminated reticle, so I'd stare through this little red crosshairs, almost like you're looking through when you look through a targeting scope, and you would follow the stars to make sure you didn't have any tracking errors. So that's 40 minutes, and that was sort of how I started learning the constellations and learning where things were. As I'd capture a big swath of the sky, and then I'd say, well, wow, what did I get? And we had paper star charts back then, laminated star charts, and we'd figure out what was in the images. Here's another 40-minute exposure, and we've had a lot of aurora activity this past year. This was my first aurora image, but I didn't even know that because you don't have a lot of color sensitivity at night, but this is a 40-minute exposure. I thought it was kind of a foggy sky. I didn't think I'd get much, but I got some low-level aurora, and then you can see the stars through that. And then as digital photography kind of came around, I started doing what a lot of people do is their first astrophotos, which is a circumpolar shot, multiple exposures, and piecing them together in Photoshop. So I was having a lot of fun. I was really enjoying astronomy, but it wasn't really serious in a way that it took a lot of my time, but I was enjoying it. What was happening as I got older is I became quite career focused, and I worked at a large high-tech firm, and I became an executive there, and I was doing a lot of work with them, and I was quite focused on those efforts. And then one day on my way to work, I was traveling on the main road, and another driver went through their stop sign, and I was in the intersection when they did that, and it did not end well for me. I ended up in hospital for over 6 months, and when I woke up after 3 days of being unconscious, let's just say that there was a lot of physical damage, including a spinal cord injury. So now I was in a wheelchair and had some other injuries, and it became quite difficult to leave the hospital. I was there for over 6 months. So I spent a lot of nights in the hospital thinking to myself, well, now what? Things have obviously changed dramatically. And so this is actual image of my hospital room from those days. And you can see up here in the corner, one of the things that happened was I bought a 3D printer. I didn't know anything about 3D printers. But I knew that I needed some sort of distraction. I was in the hospital for a long time. So I just ordered a printer and had it delivered to my room in the hospital. And I started printing things for the staff at the hospital. If I got to know the staff and they were being friendly, and I got to know the things that they liked, I would download different models, and if their favorite hockey team or their favorite movie or their favorite TV show or whatever, I would print things out for them on the 3D printer. And I started learning how to design things and how to use a 3D printer. And then eventually, after a little over 6 months, I left the hospital and then started a phase of rebuilding my life. It was not really possible for me to return to work. So I became quite focused and designed a wheelchair accessible house. And then when the house was built, I moved the 3D printer into my garage, and that's it there in the picture. And I started working on other things. It's like, okay, I'm in a wheelchair now. What can I do to make astronomy accessible to me again? Because it's very difficult to manage a telescope in the wheelchair. So I started building these motorized bases that I could set up a telescope on, and I built a few of them, and I started taking my telescopes out. I started having some early success in, let's say, higher magnification astrophotography. There's an early image I took of the Veil and the Elephant Trunk Nebulae, and it was actually going reasonably well. I was having some fun, but I started having problems because I had to set up my telescopes out in the front where I could get with my wheelchair, and I kept on having thieves like this young person. I expect they're young. They stole the tablet computer off. And also the city of Guelph upgraded their lighting, and I started getting it was like daytime in front of the house, and it was becoming very difficult to do astrophotography between the thieves and the city. So it's like, what in the actual focus am I going to do now? I mean, I can't, I put all this effort into setting up to do astrophotography. And so I went back to the drawing board, and there's actually a company that makes these sky sheds. And so I downloaded the plans for a sky shed, and then I started learning how to do CAD. I redesigned the sky shed so that it was wheelchair accessible. And I put a couple of, as part of the sky shed, you get the plans for a pier, and I adapted the pier a little bit more for my needs. And so I made these plans, and then I got help. And I've had a lot of help since the accident. And let me just, if anybody is on tonight, you know who you are, that helped me in this journey. There was a lot of help. And we started building this wheelchair accessible observatory. And here's just a very quick little tour. We used barn board for the outside, but on the inside it was some good little astrophotography scopes that I set up. And that was the journey back into astronomy. And this is still the setup that I'm using today. And with that, I've been able to get some pretty interesting astrophotos, and that was pretty exciting to be able to start doing real astronomy again. That's obviously the Andromeda Galaxy, and then here's a shot of the Tadpole Nebula that I did, and I've sort of done some layering and added some motion in here so that you get more of a feeling that it is obviously ionized gas. So you get this feeling of looking through the gas and the different distances of the objects. So that was great. It was actually happening. I was doing astronomy again, and thinking to myself, is this my purpose? Maybe this is my purpose, to start doing astronomy again. And then another twist in the road, but this one a little more pleasant. I got a request from my niece. She looked at my telescopes, and I didn't know that, but she had quite an interest in astronomy. She didn't talk about it a lot, but she wanted her own telescope, and she said, Uncle Brian, how can I get a telescope? So, and I'd been kind of having this secret love of truss style telescopes myself. I always wanted to build one, and I'd done a little bit of telescope building before. And so I started thinking, well, maybe I can use my 3D printer and what I've learned about 3D printing to do something. So I started thinking about, well, how can I build something strong enough to hold a telescope and to be a telescope? And I started quite a 3D printer learning curve, as I wanted to use very industrial strength plastics to build these telescopes. And some of these plastics, like ABS plastic, that's what these pictures are of. My very early attempts at printing with ABS plastic. And it's the same plastic that's in your car bumper, right? It's a very tough plastic, but incredibly, well, very difficult to print with, let's say. So I had to learn how to print, and part of it was things like adhering the plastic to the bed so it's not deforming as it's cooling. All these different challenges in 3D printing. This is a picture of my 3D printer with its cracked bed, because when the plastic adhered too well, you had a different problem, and that was you'd crack the print bed. So it was quite a technical challenge, and started doing things like building these enclosures that could contain the heat of the printer and make the results more favorable. So as I was solving the actual printer problems, I also needed to design. So I got inside of a CAD program called Fusion 360, and I learned how to use it and started prototyping for my niece the first telescope. And as I built that first prototype, this wasn't actually the telescope for her. This was just testing concepts and seeing how things could work. And this is actually my niece trying out the first prototype for the first time, and it's still not fully assembled, but good enough to do some terrestrial viewing and show her what it could do. And see, obviously this telescope, the way it was far too tall, because as you can imagine, if you point that telescope at the zenith, she wouldn't be able to reach the eyepiece. So these were all the things we learned with the first prototype. And then once I had the prototype made, I started printing the parts for her actual telescope. And then when I had all the parts, I had her come over, and she actually assembled her own telescope. And we tested it out. And you see, this is a much more appropriate height for her telescope, because she could look at zenith and see. So she was, here you can see the first prototype in her telescope. So she was happy, and that was great. It actually felt really great to do that for her. So since that worked pretty well, I thought maybe I should make more. So I set up more heated enclosures with more printers, and like the way a lot of us collect multiple telescopes, I started collecting multiple 3D printers. And I started running those printers, running different parts in them, and started collecting together the parts to build more telescopes. So that's just a stack of parts. Those aren't actually assembled. They're just sort of the parts collected into each respective color. So then I started looking for volunteers who wanted to help me build and engage the public with these telescopes. So on the left is Emily. She's one of our first telescope builders, and Terry on the right. So Emily and Terry have built a number of telescopes. Actually, Terry on the right there, he's actually doing a collimation. We call him our chief collimator, and he's pretty good at it. And Emily is just our fastest and best telescope builder. And here's so every telescope has a name. This particular telescope is named Babylon, and this is Terry doing collimation on Babylon. And so every Sunday we get together, and we still get together every Sunday, and we build telescopes, and we help other people solve their telescope problems, or if somebody needs something printed for their telescope or designed for their telescope to fix it, they can come and we'll measure things up and we'll provide solutions. So I mentioned that all of our telescopes have names. Actually, at the back there, Terry's collimating Bumblebee, yellow and black. And here's Canuck. No, actually, that's Clifford. This is Clifford, like the big red dog. And then this one here that Elliot's working on, this is blue and orange. We call it Blort Simpson because it's blue and orange. We name everything around here. Printers, telescopes, we name everything. And then we needed a place to put all these outreach telescopes. So we set up something we call the Blue Door Astro Library. So it's really just a nice shed with a blue door on it. So that's in my yard. And so this is a picture inside the Blue Door Astronomy Library. So these telescopes are not finished yet, but this is an early picture inside the library. And then we decided we'd call ourselves 10 telescopes, because our goal was to have 10 telescopes for the Guelph and surrounding areas, and we would loan those out. And so we got a website, and then we started getting more attention. We got interviewed on CTV and CBC, and some bloggers interviewed us, and it was quite exciting to see how much interest there was. And then the Blue Door Astro Library, there's actually a section on our website that shows all the different telescopes. We have 18 telescopes now, so you can see Babylon and Barbie, Blort Simpson. This is Superstar Bumblebee. That's Canuck, Matrix, and there's more. We have about 18 scopes, and we have like 3 sets of high power binoculars. We have various things that you can borrow. And we started doing events. So one of the things about events that we didn't like, though, was that how often there's clouds. So we started coming up with these concepts for telescope games, and we would use these backlit panels with different targets on them, and young people could come, and we would say, okay, now find the banana, and on one of the panels, hidden amongst all the images, would be a banana, and everybody would race to see who could point at the banana, and then they put up their hand and step away from the scope, and then a judge would come up and say, yep, you found the banana, you've won. I think we were giving out candy bars, maybe not the healthiest choice, but the kids were motivated to win them, so they learned how to use and point these. Well, they're supposed to be easy to use, these telescopes, and it turns out they had a lot of fun learning how to use them. And then we did a Symphony Under the Stars this past summer with the Guelph Symphony Orchestra, and that was a lot of fun. And sometimes a local school will ask us to come and they'll borrow a telescope from us for a month to just be in their classroom, and they'll get familiar with it, and they'll test it out a little bit. And then we'll come and we'll do an event with them on one evening. This was Manchester Public School in Cambridge. We went and did an event with them one evening. And yeah, so we continue improving the designs. One benefit of lending out these scopes all the time and building so many of them is that you get to know the design. You get to know everything from usability, buildability, all the things about a new design like that. And this is the Fusion 360 program that I use to design. Oh, and this is actually one of our. So we have 18 scopes in the library. But we also have telescopes that people all over the world have built from our plans that are offered on GitHub. This is the telescope owned by a young man in Germany named Carl, and he likes Canada. So I actually customized our scopes to kind of have a bit of a Canadian theme. Not too subtle, I know. And so he built one of our scopes, and this is a picture of it in Germany. And he likes going up on there's some local hills that he likes to go up and do terrestrial viewing with his scope up there. And here's 4 of the scopes that have just been. This is Blort Simpson. We have one called Ducky. I kind of have fun with designing the cores of these alt bearings. This is Barbie. It's one of our first telescopes. I think this might be the second telescope we built, second or third. And then Swamp Monster. We try to have, some of our scopes look very serious, but a lot of them are quite fun because they are for engagement. And at the same time that we're building telescopes, we also 3D print and customize and design our own 3D printers. So here are our 3 printers kind of in the process of getting built, and here, actually, just behind me here, I don't know if you could see it when we started the presentation, but behind me, I guess in this room there are 7 3D printers. Here are 5 of them, and these are called boron printers that we've printed and assembled these printers here, and they print telescopes. And in case any of you haven't seen what it looks like when a 3D printer actually prints things, here are some. That's a time lapse. I wish it printed that fast. We do not get to print that fast. I certainly wish we could. But you can get the idea of the layer by layer by layer printing process. And then we have to make sure that we're well calibrated so that all the parts fit together quite nicely. This is a red dot finder fitting onto the spider assembly. Oh, and we do some custom scopes for, Orbax mentioned the Griffin scope that we built for the University of Guelph. This is actually the great Orbax himself using the Griffin scope. Actually, that was the night, that was at the Symphony Under the Stars night. We just finished it, and I asked Orbax if he would come to the event, and we delivered his scope to him that night at the event. And he got to use it for the first time while the symphony was playing in the background. That was a great night. And something, because I've released the designs to these telescopes on GitHub, I wanted to make sure there was a good way to access parts for anybody that wanted to download these designs and print them themselves on their own printers. We actually have an online store where you can download. We kind of have more affordable packages and then more premium optics. Like, we offer some spherical mirrors for more budget conscious builds. And you'd be surprised how good a spherical mirror is in making, the moon look stunning, the planets still look good. Yeah, there's a little bit more contrast to a parabolic mirror, so we offer those, but they are more expensive. But anyway, we try to offer, and our main target is schools. So if a school wants to build a telescope as kind of a class project, and they have a 3D printer, they can download the designs and make their own telescope. And this is the workspace. Oh, and there's our big printer. That printer is called Hevorange, and it prints 600 millimeters. Basically, it can print a volume 2 feet by 2 feet by about 2.5 feet. So you can print quite large things in that printer. And then we have some workspace because my dining room table was getting too small for all the things we were doing. And so the young man, Carl, who has a telescope in Germany, was an exchange student here for about 6 months. And he took out the Superstar telescope and we put it on an equatorial mount for him. And he took our first ever astrophotograph of the Whirlpool Nebula. And that was pretty good. I think it's two frames of 3 minutes. They're f5 telescopes, so it doesn't take that long to get an image. But then just last week, a young man named Vassar came in, and he actually took the same telescope that Carl used, and we modified it because he wanted to put a pretty large camera on it. But it was a DSLR, so the back focus on it became problematic. The focusing tube ended up impinging into the OTA too much. It was blocking too much light. So we customized it, we cut it up, and we put a way for him to mount a guide camera on the back and a little astro computer on the back. These little dovetail things. So you can see the ASI Air, which is the astro computer on the top there, and you can see the guide scope he put in the other dovetail. And the nice thing about these scopes is the way they're designed, you can slide the mounting. You don't need a super long dovetail because you can just move the dovetail up and down the body of the telescope, which is what he did. And he was able to balance with these very, very massive, it's a cooled Canon 6D, very large, very heavy camera. And he mounted it on there and got it balanced. And this is the result that he got. So this is 45 minutes of exposure, and yeah, we were quite happy with that result. So on to the main event, which is talking about how a Skyward 150 gets built. So let's say you were interested in building one, or your school was interested in building one. What actually happens? How does that get built? Well, this is the top view, a cross section of the OTA, and it is a Newtonian reflector. So light is coming in, from the front of the telescope, bouncing off this parabolic or this concave mirror at the back, and then bouncing up to a secondary mirror, and then coming out the eyepiece on the side. So what does it look like when that's getting built? Well, the first thing we start with is ABS pipe, like you get at Home Depot or Reno whichever hardware store you like. and then you can put these 3D printed feet into the ABS pipe. So we wanted this to be a very affordable, very accessible way to build a telescope. So this is why we tested out the ABS. We tested out a few things that anybody could get locally, and we like the ABS plumbing pipe. And then on top of the ABS plumbing pipe goes the tripod apex. And this allows you to fold the legs in so that it can get into a more compact car, because not everybody that borrows our scopes or wants to transport our scopes has got a large vehicle. And so it is foldable. And then we put in these cross braces, and that's just more plumbing pipe, a slightly smaller size, and it goes into these little clamshells on each leg, and that makes so I think I mentioned my department store telescope when I was a kid. That was a very frustrating telescope to use because it just wouldn't sit still. You know, you'd be looking at the moons of Jupiter or whatever, and you know, the slightest breeze or if you touched it in any way, it would shake like crazy. So we wanted to make sure that we didn't make a frustrating telescope. We wanted it to be stable. And so on top of the tripod apex, you see those little square patches. Those are for Teflon material. We did some experiments, and Teflon, when combined with ABS material, which is what this rocker box base is made of, ABS material and Teflon, they actually have very nice friction coefficients. The static and the dynamic coefficients of friction are nicely matched, so you get that very buttery feeling when you're moving it around. And these are the sides of the rocker box you can see here. So the telescope ends up sitting on top of that rocker box, and you can see here where these little pad places are. We put more Teflon there for the alt bearing. And then we'll do the rear of the mirror cell. So that's the mirror cell cap. And then these are the collimation bolts. And then, of course, these other bolts that hold the assembly together. That's for doing collimation. So that's the actual mirror cell. The mirror goes inside of there. And this is the rest of the mirror cell body. And then this is mounting tape that holds the mirror to the actual mirror cell. And then here comes our mirror, 150 millimeter mirror, and then a retaining ring. Just in case the mounting tape were to fail, we want to make sure that our mirror doesn't get away from us. We've never had mounting tape fail, but we put that retaining ring in there anyway to hold the mirror. And then you can see at the back here, these little things here are for balancing the telescope. We call it dead weight. So you can put dead batteries in there to balance your telescope. Let's say you put your cell phone at the eyepiece and you need to quickly balance your telescope. You can just throw dead batteries in there, and that was our least expensive way of counterweighting the telescope that we could think of, that a lot of people might have in their, in their key drawer or their junk drawer would be some dead batteries. So might as well give our dead batteries a little bit of a purpose in life. And these long pieces here are called aluminum extrusions, and they hold the entire telescope together. And then with these extrusions, those little T-nuts can slide in there, and they can hold different things in place. So, and now our alt bearings are coming in from the sides. There's kind of an inner ring and an outer ring to the alt bearings to kind of hold it onto the assembly, and also makes for some unique color design opportunities. And then our baffles come in. So now you can avoid the stray light and also keep condensation out when you're imaging. Some more T-nuts. Here comes our spider. Our spider holds the secondary mirror, and it's all part of the spider assembly there. And then our secondary mirror holder, it's on a 45-degree angle to kind of bounce that light out towards the eyepiece. Here comes our secondary mirror. It goes on mounting tape as well. And then here's our front baffle. And so this whole thing just slides onto those extrusions. And then we can bring in our dust cap. It's also a batten-off mask and an aperture mask, and these little plugs go in there so that it can do multiple duties as a batten-off mask or or an aperture mask. And then here comes our focuser and our red dot finder. Put our fasteners in, and here come the batteries. So you can put quite a few batteries in there to counterweight. Emily, our scope builder I mentioned before, she has this massive phone. So that phone takes almost all those batteries to counterweight. I can't believe how big some phones are. And that is how we build a Skyward 150. And that's pretty much our factory. Thank you for visiting. I did want to mention some things that we have coming up next. We're working on a Skyward 150 compact design because the current Skyward 150 is a little too big to fit on some printers. So we need to make a redesign so that more people could print them in more schools and more amateurs and people with 3D printers at home. Sponsored school kits with instructional videos. We're working on that. We're working on an economical coma corrector, just a simple 2-element coma corrector. Because it is an f5 scope, it does have some coma as you get off into the periphery. So we're working on that. We're working on a big 8-inch telescope, or bigger 8-inch telescope design, and a premium 2-inch focuser for that 8-inch telescope. And we're also working on, because these scopes are mostly set up for visual, not so much for astrophotography, we're working on an economical harmonic equatorial mount, which will be really good, we think, for that 8-inch scope to allow people to do some serious astrophotography. And that's it.
Well, thank you so much, Brian, for everything. That was an incredible talk. I'll point out again, if you do have questions for Brian, to bring them up in the comment section so we can take a look at what's going on. In the meantime, though, I mean, so we have a pretty broad spectrum of people who are watching right now. Those who have some astronomy experience, those who are just interested, and I like the fact that your talk kind of spanned the breadth of all of that. And an important thing that I think is kind of an interesting thing that maybe you could speak a little bit to, because you showed it in your presentation, was the first astrophotography images that you got from the Skyward 150 was that black and white image of the spiral galaxy, right?
Yep.
Now, it's interesting to me because every picture that I seem to see of astrophotography looks like the backdrop that I have below, rampant with colors, beautiful imagery, and just this amalgam of something that looks like it's from a Marvel movie. Can you explain what you actually see through a scope, what you see by putting several images together to create that first image, and then what is this appearance of colors? What do they mean? I know a lot of the RASC people already know this, but from people who might be watching from our end who aren't as familiar with astronomy and astrophotography, can you give us some details as to that?
So that's a great question. So I'll start by comparing a little bit between visual astronomy and astrophotography. So with visual astronomy, which is the original purpose of the Skyward 150, is to act as just something, you set it up in the yard, you point it manually, there's no motors, there's no power required, you point it and you look at targets, and as the Earth rotates, things are slowly drifting across the field of view. And typically, unless you're looking at a bright target like Jupiter, where you can see some color, most of what you see with your eyes is falling to the rods of your eyes. Instead of the cones in your eyes see color, the rods are more sensitive, but they really only see black and white monochrome. And so usually when you're doing visual astronomy, you'll see faint wispies, and it'll be very monochromatic when you're looking at things like galaxies and nebulae. And then when you move into astrophotography and you have to move to tracked, actually we had somebody, what did he shoot? He shot the Ring Nebula using his cell phone with an untracked Skyward 150, and he got the Ring Nebula. I couldn't even believe it. But that's very rare. Most of the time you're using a tracked telescope, and that telescope stays on target for usually hours, sometimes many hours, and it pulls out the color that your rods can't see when you're doing visual astronomy. That's not to put down visual astronomy. It's amazing because you're collecting the photons with your own eyes. You're pointing, that tactile feel of pointing the scope and then sort of saying, I pointed it at this thing and I'm seeing these photons that are coming from, often, many thousands of light years away, or sometimes in the case of some nearby galaxies, millions of light years away. And that tactile experience is quite remarkable. But when you move into astrophotography, you've got a camera set up, it's cooled, it's collecting like single photons and adding them into a signal that can then represent color. And then for example, in my astronomy setup here in the city, we use filters like bandpass filters that will pick off very specific wavelengths that you can render into color and create these brilliant, because the opportunity is to present to the human visual system, which is a full color visual system, and you get a lot more information from color if you represent things in color. So you assign a gas to each of the red, green, and blue colors, and you can create these very vibrant images. And yeah, so the different ways you use a telescope will provide for different experiences. But a lot of these astrophotos they're challenging. It's very challenging and often very expensive to do good astrophotography. We're trying to make it more reasonable with this project, but.
Oh, absolutely. But I think it's an interesting thing because, it's when you bring people to physically do visual astronomy and to take the telescope, to get their hands to take a look, and they look up and they're looking at the Orion Nebula and they see it just hanging there below the stars, and they're like, is that just a smudge on the camera there, or is there's just bird poop on that, or is it the actual thing? And I think it's a little bit misleading sometimes when you see all these incredible astrophotography images. It reminds me a lot of different types of field microscopy, where you're representing different things with the colors rather than them being the true colors themselves. Anyway, I just always like to point that out at the beginning of an astronomy time, because when we bring people here to the observatory, one of the things that they look at, it's amazing to have them see Saturn for the first time and see that light, like you said, photons from our sun to Saturn back again, coming to their own eyes, and it just looking like a golden sticker that you would have on your ceiling, and still having it blow their minds even when they can't see the subtleties of the color.
Indeed.
Yeah. It's interesting. Nader, I'm taking over the conversation. We've got lots of great questions here in the chat I can hop to, but I want to give you an opportunity if you had anything to ask Brian.
We're having a few questions coming in from our viewers on Rask Montreal YouTube channel here.
Okay. I can bring them up. I can bring them up on screen. That's a thing I can do.
Yeah, sure. Juliana is asking if you've ever thought of doing refractors.
We have refractors.
All right, moving on.
Is there any challenges for doing refractors? Why is the choice of a altered Dobsonian Newtonian?
For in order to get into an affordable refractor, you often are using a fairly simple doublet lens. Crown and flint glass is usually what you would use for a beginner refractor. One of the things though that you have like this purple fringe that people often see and talk about. And so I really wanted these to be an affordable, accessible. So to get a 6-inch aperture telescope, even with just a simple crown and flint optical system of a refractor, it would be quite expensive, and you wouldn't get those quite the same sort of crisp feel. You'd still get some of that purple fringing that cannot. I really looked at the price performance. I said, okay, we can build a 6-inch scope that will give some impressive views at an affordable price, and that's where we started. We could certainly do some designs with refractors. So we definitely could. A good refractor is an amazing instrument, but that's just the price performance. This is the route that we chose for our first telescope.
Awesome.
And for those who do not know what a refracting telescope is,
right?
Can you give them that little?
Yeah, I mean, imagine. I don't know how many of you played with magnifying glasses when you were kids, but it's basically what you're doing with any telescope is you're taking light, you're converging it to a point, and then you're taking a smaller lens, and it's almost like you're pointing that magnifier at that point where all the light is converged. And there are different ways of making that light converge. One is with a mirror, almost like a makeup mirror. If you've ever, I'm sure a lot of you have seen makeup mirrors where you look at them and then you kind of move back, and all of a sudden your image goes blurry and then it inverts. They're quite fun to play with, actually. But that's one way of getting the light to come together, is a mirror, which is what we use. And the other way is to use a lens and to get the light to converge that way, almost like a magnifying glass. So one's like a makeup mirror, that's our style. One's like a magnifying glass, that's the other style. And then you just point an eyepiece at the output of either that mirror or that lens. So the lens is a refractor and the mirror is a reflector.
So basically, it's lenses versus mirrors.
Yep, that's right. We chose mirrors for this first telescope.
Mirrors win.
at least here.
I have maybe more of a suggestion than a question from Zapfan, asking that well, basically you've built your own 3D printers. Maybe you could consider building a machine to grind your own mirrors.
Ooh. So we only have a 40-minute talk tonight, but it's already one in the works.
We can move on from this.
Yeah. Well, I've ground mirrors by hand before, and that's quite an interesting process. I mean, if you could also, I think, get into Zen Buddhism at the same time. I mean, it's very
tedious and
well, hypnotic.
of
Let's say hypnotic or meditative. Let's say. But yeah, I've kind of got the beginnings of something called a mirror-o-matic.
I like the sound of that.
Yeah, although I'm not too sure if it probably won't just be the final design, but it's in somebody else's design that I'm learning from, and then we'll see where that goes from there.
Okay, so Zap fan, keep tuned in.
Yeah, right. It won't be happening this week, but it's happening.
We also have Pierre Tanguay asking, when would the Skyward 150 Compact be expected to be available?
Oh, wow. What a great question. Here, let me show you something. All right. So so you can see here over here. This is Swamp Monster. You can see the little Swamp Monster here. So this is the original rocker box. But this portion here of the rocker box is quite big to print. So what I've been doing is I've been designing a new rocker box, but we also have to make a smaller. Oh yeah, I've got that here too somewhere. We have to make a smaller. We have to make a smaller alt bearing, so you can see how much smaller this alt bearing is. So we actually have to make a taller rocker box. So this is, I hope you can see it. So this is the, I guess this is the front here. So this is the front of the new rocker box design, and this is the side, and then, the alt bearing will rest. I mean the outer ring, I have a piece back there, but this is the new one, and this will print on a. For example, bamboo printer or Creality printer. It's designed to print on some of the smaller printers. So
is it just the rocker box and the bearings that are smaller? It still holds the same size telescope on it, or are you making a smaller telescope to go on there as well?
That's right. The OTA on the original Skyward 150. This OTA will print on a smaller printer. The problem was some of these other parts that were too big to print on a smaller printer.
As a follow-up, would there be an option to get rid entirely for the wheels and attach a Vixen-style dovetail at the bottom, for example? Or
that's exactly what we did. Let's go back to I can throw back to the presentation here. Oh boy,
the guy from Germany with the
yeah, him and Vassar. Let's see, where were you? There you were. So let's bring up this slide. Let's go back to presentation mode. Sorry, it's just take me a second here. Let's go back to here. And then doop, 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 doop. Okay, you can see here on this image on the right, this is actually on an equatorial mount. So you can see this black ring on the far side that we've replaced. So we actually 3D printed, it's actually a 3D printed dovetail.
Right.
And yeah, that's, so this image that we showed before, that's taken using the 3D printed dovetail. So we can put anything we want inside of that circle. In this case, we put a dovetail.
So it replaces one of the two wheel bearings?
Yeah, that's right. That's right. It replaces that. Actually, the bearing is still there. It's just in the center of the bearing is a dovetail. Yeah. So that's a great question. That's exactly what we've done.
We still have one last question from the chat. Jane Lubensky is asking, what would be the approximate weight for an 8-inch Dobsonian that's in the works?
For 8-inch, so the one that's coming up.
That's yeah.
Well, let's think here. So right now, this fella, just the OTA is about 12 pounds, 12.5 pounds. So I'm going to say probably getting in on 20-ish pounds. I haven't built one yet. So, yeah, no, the glass is also thicker.
I think one of those things, too, to point out is that your designs are incredibly portable and they do break down, right? So it's not like you're hauling you're going to be hauling a 20-pound scope out of your car and hauling it all the way up. You know, you can take these things apart into pieces and then make your way up to wherever your observing space is.
Yeah, I think often the questions, though, are people that own an equatorial mount and they're trying to determine, okay, will my equatorial mount handle this scope? And I'm going to say 20 pounds, but let me build one first, and I'll let you know. I've already got the mirrors. I know that my 150 mirrors are 750 grams for the mirror. So you're probably getting into 2 kilos probably for an 8-inch mirror, probably close. So, you know, that's a significant part of the weight. So I don't have an answer for you, but stay tuned. It's coming.
Now, speaking of holding up a 20-pound telescope out of the car and trekking and walking to a location, I wanted to ask, with your mobility at the time being, do you encounter unique challenges to access to observatories or to star parties, and what would be something that us as astronomy clubs and astronomy communities could do to facilitate access to mobility challenged individuals?
This is a really good question, and it's so if I'm being completely honest, even my design, let's bring Swamp Monster up here. Even my design, I can sometimes use this telescope myself, but only when something is kind of between this angle and this angle, because, you know, I can't because of my spinal cord injury, I can't just stand up or crouch down or whatever to meet the eyepiece. So one thing is that when I go to star parties, I don't even use my own scopes. I end up using this refractor because I can kind of get behind it and kind of, you know, it's a little bit more friendly for me to point at various targets. But one of the things that I'm working on, I didn't mention it in the list because it doesn't have such an impact on the people who will borrow scopes or use my designs. This would be a design for myself. But one of the things that you can do with these scopes is you can move this. I'm oversimplifying a bit, but you can take the secondary mirror that's at the front here, and instead of it being at a 45-degree angle, you can flatten it back out. So the light comes in, hits the big mirror at the back, then comes back, hits this other mirror again, goes back to the back again, and then your 45-degree mirror will be back here inside the alt bearing. So now, no matter where you point, the eyepiece is always at the same height.
Right.
So this is a design that I'm working on in the background, is to make a wheelchair accessible. I actually have a 15-inch mirror in the shop, and I'm working on a design like that. So it'll be a big scope, and so just be able to wheel up to it and put this eyepiece. And now the other thing is that the wheelchair needs to move around with the rocker box.
Yeah.
So the rocker box will be connected to a platform, and the whole platform will turn with the telescope and keep that eyepiece at eye viewing. So this is a little pet project that's in the background, but what a great question. Yes, it's not easy. And so my short-term fix was to build the observatory and put cameras. You know, if you put a camera in a telescope, you can do your observing from bed if you want to, right? Like you don't have to, there's no physical limitation to it, which is why I built the wheelchair accessible observatory that I mentioned earlier. But for visual astronomy, yeah, it's not the most accessible. If you've ever been to an observatory, like a serious, like university or institutional, a serious observatory, there's no chance. There's no chance of using those telescopes from a wheelchair. But yeah,
right.
Great question. Thank you.
Well, thank you very much. I have one last question for you. I don't know if anybody else is gonna chime in with more questions, but I wanted to know that you provided all of your design or your 3D printing design on GitHub as open source.
That's right.
What motivated you to go the open source approach, and what was the community's response to this offer?
So we've had people build scopes in like Australia and South Africa. We've had a few different. We've had a number of people building these scopes and having success with them. The reason that I did it was, maybe I'll try to go with the short answer. I was part of a group where we designed a CNC mill called the Millennium Mill, and that was an open source project, and I just loved it. I loved that that we were making something. I was a small member of the team. I wasn't leading that team, but I just loved how we were making that design so that people could build their own CNC machines for very little money, and they could learn from that community. And so I really modeled this after that experience, where okay, how can we do this in a way that it's just really. And if I'm also looking back at my experience after the accident, all the help that I received from various people that were very generous with their time, I kind of just wanted to put something back out into the world as sort of a thank you.
Just a paying it forward.
Yeah, pay it back, pay it forward. Yeah.
I just want to mention that a lot of people on the chat have been sending thank you messages from Daniel Provençal. Congrats on a great telescope design. David Schumann, really awesome to see this. Hey, Ray, thank you for your presentation, especially the impressive animation watching from Windsor, Ontario. And I don't know if I'm going to go up all the way up in the chat. Will be a lot of similar messages. So thank you very much for your time, your presentation, and your inspiration. And I'm handing the floor back to the great Orbax for.
That's good. I was going to mention those in the wrap up as we ended, but that's all right as well. And of course, you know, there was a message here at the very end that mentioned to leave the details on how to contact you and find your telescopes online. So, Brian, plug away. How do these people find you?
You ready for my shameless plug? Obviously, 10 Telescopes is the name of our organization. So we have that URL 10 spelt with a TEN, 10telescopes.com. And so if you go to 10telescopes.com, a lot of what you'll see right on the main page there, you'll see the Discord address and you'll see the GitHub address right away. That's like right there. And then the blog, that's where a lot of the action is happening. If we have anything to say, it's all on the blog. So and then on the Discord, if you want to interact with us, almost all the volunteers are on the Discord. So if you have questions, you want to build one, or you want assistance in building one, you want to see what other people have built, you can come on the Discord and you can talk with us or see what other people have been posting about. And yeah, we'd love to see you. I would love to see some more traffic on the Discord. That would be great. So so just 10telescopes.com, and then if you want to engage us, we're on the Discord every day. So we'd love to see you.
And tons more positive messages flooding in. Many thanks for a great talk, great presentation. Thank you for being such a creative and generous person. I assume all these are directed towards me, so I would like to thank you, the audience, for mentioning that as well. Nader, any last plugs from you and for RASC Montreal Centre?
Just for anybody who's joining for the first time, head to our website, raskmontreal.org. We have a calendar of events on the front page, and if you subscribe to our newsletter, you'd receive a lot of our communications that will let you know what's happening at a observation place near you.
Fantastic. And of course, you can find us at Guelph Physics on YouTube, on Facebook, and on Instagram. And coming up in a few days, we'll be dropping our February stargazing guide. A little late, but hey, better late than never. And before we completely disappear here from online, Brian, I want to ask you one last question. This was a long time Guelph live stream question that was instigated initially by one of my previous students, Mel. And she always had this great question that we used to wrap up with, and I'll ask it to you, Brian. And that's this: what was your favorite day that you could remember, or favorite story of a day that you've had doing your research? So in your case, in your observatory, in your studies, building these devices, what was the best moment that you had that either sort of told you, I want to keep doing this, or was just one of those things where you're like, man, what a life we get to live?
You know, it would have to be building the telescope with my niece. She came over and she spent the weekend, and she was running the power tools, and she was having a great time building that telescope. And that was it. That was the moment that I decided I have to build more of these. And what a great question. But yeah, that was definitely the moment.
And I mean, it just goes to speak to this idea that you know, astronomy, I find astronomy, unlike so many of the other things that we study in physics, but brings everyone together. It's something that everybody has access to, or everybody can have access to, just even simply by looking up and taking a look at the stars that are above us. And I think you're hard pressed to find somebody who hasn't looked up and wondered what's going on up there. And I mean, with groups like RASC and individuals like yourself, Brian, who are creating these telescopes and getting them into people's hands, you're making it even more accessible for young people to get interested in it. And I got to say, if you've got a junior scientist at home or somebody who's STEM minded or STEM interested, and you know, we can't all afford all of these experiments you see on your March break, suggested experiments to do with the kids or anything else, but I think we can all take them outside and take a look up. So
Yeah,
if you've got somebody who's interested, astronomy, I think is something that everybody can.
Yeah. Well, if you're anywhere near Guelph, come borrow a telescope, take it home for a month, and enjoy it. I mean, there's nothing. We've got one family. I think they've been here 8 times, borrowing books, borrowing telescopes. I mean, it can be very affordable, and I think a lot of libraries are doing some things like this, but it should be affordable. You're right.
Yeah, it should be. It's incredible stuff. Well, thank you, everybody. Thank you to our speaker, Brian. Thank you to Nader for joining us from RASC Montreal Centre. And most importantly, thank you to you, our incredible audience who sat with us and learned all about this. If you're interested, remember to go to 10telescopes.com. And to check out the RASC sites for an RASC group that's close to you. I'm the Great Orbax. Thank you so much for joining us this evening. And don't forget to take some time to look up. Hope you have a science-tastic day, and we'll see you soon.
Thank you very much. Have a good night.
Thank you.